Science mission begins for NASA's new eye on the X-ray universe. Our space is one of nature's most complex phenomena. As humans, we cannot even comprehend what is out there. So we have technological machines that help us in this regard. But sometimes even these technological marvels can't match the greatness of what the universe has to offer. Then again, that is a sign from the universe to improve our technology to discover its secrets. One secret the universe has hidden inside space is the X-ray universe begging to be discovered. Before we continue, make sure to subscribe to this channel and press the bell icon to get notifications on our upcoming videos. As for NASA's contribution to this entire plan, it has launched a satellite on December 9th from the Kennedy Space Center on a SpaceX rocket. That's right, the relationship between the American Space Agency and Elon Musk is getting better by the day. This rocket has begun to observe our X-ray universe, and it is set on a mission to study the black holes and the entire layout that has been left behind by the exploded stars. What is X-ray universe? Studying the X-ray universe sounds pretty tricky, and that is because we haven't fully grasped the concept of an X-ray universe. An X-ray universe is an area in our universe where particles have been energized dramatically due to high energy or elevated temperatures. This happens due to strong magnetic fields, explosions, and gravitational forces that are incredibly strong. To study the X-ray universe better, NASA is building such equipment. To unravel the secrets of this universe, the right equipment needs to be in place if we have to have a shot at discovering this part of the unknown. The area of an X-ray universe is quite complex. It's not as if it contains things we haven't heard of before. Still, a 6-month study managed to show that there are more significant things out there than millions of sources of X-ray radiation, including giant black holes, galactic clusters, and supernova explosions. The third one of these out there is unknown to us. And this is what the X-ray universe is full of. A field like this is simply waiting to be explored. And if we do not speed up the process of improving our equipment, we might miss some important moments because of our slow work rate. The space mission. The Imaginary X-ray Polarimetry Explorer, or IXPE mission, is a partnership between NASA and Italian Space Agency funded by NASA. The current budget stands at $214 million, which is only expected to increase. On the other hand, the Italian Space Agency was the one that provided the X-ray detectors and a ground station in Kenya to receive scientific data from the satellite when it does fly overhead. This joint venture was launched at the start of last month and was sent abroad on a SpaceX Falcon 9 rocket, which delivered the satellite to a unique equatorial orbit at an altitude of about 600 kilometers. After separating itself from the Falcon 9 launcher, the IXPE spacecraft has spread out its solar panels and has managed to ace all the tests it was put through. On December 15th, less than a week after its launch, the IXPE extended a boom shaped like origami as it held the satellite's 3 X-ray telescopes, giving the satellite a length of about 17 feet from one end to the other. This extendable boom is the correct length that allows the mirrors of the telescope to focus X-ray light back onto the detectors inside the main body of the spacecraft. This allows the IXPE satellite to record high-energy waves, which are emitted back to it by black holes, neutron stars, and any other celestial bodies that might emit intense X-rays that are unable to be recorded by the other telescopes present in space. The two most important telescopes present in Earth's outer atmosphere are the Hubble telescope and the James Webb Space Telescope. The commissioning has been completed, said Martin Weisskopf, IXPE's principal investigator for NASA's Marshall Space Flight Center in Huntsville, Alabama. The two most nerve-wracking elements of the commissioning were the solar panels deploying and the boom deploying. Upon completion of the boom extension, the ground team spent around 3 weeks checking the observatory's capabilities and aligning the telescopes. During commissioning, all functions of the spacecraft were activated and verified. The IXP's mission will carry out some historical explorations, and NASA will make sure that it does. Several images have been released already that tells us that there's so much more to the X-ray universe. The Chandra X-ray Observatory shows us that the Cassiopeia A, a remnant of a star, exploded in a violent supernova event around 350 years ago. The IXPE mission observed the Cassiopeia A, and its image is quite breathtaking. Weisskopf also added, "By doing this mission, we are adding 2 variables to the astrophysics toolkit to understand these sources. That's the degree of polarization and the direction associated with polarization. Cassiopeia's explosion sent matter from the star's interior out into space in all directions at almost the speed of light. This leaves behind the collapsed core, which is a neutron star. The observations will yield insight into the magnetic field that surrounds the neutron star. IXPE mission specifics. IXPE is one of the several X-ray universe-related missions carried out by NASA. The significance that IXPE holds is that it's the first to measure the polarization signal of X-ray light. The telescopes in the past detected cosmic X-rays that imaged X-ray sources in high angular resolution, measured their spectroscopy or chemical fingerprints, and studied the same variation of X-ray signals. The polarization of X-ray light is a measurement of the direction of its electromagnetic field, and it is a signal that manages to inform astrophysicists that there are highly extreme environments around black holes as well as humongous objects such as supermassive black hole present right at the center of the Milky Way. The 3 identical telescopes that the IXPE have in their inventory can manage to measure the position, time of arrival, and most importantly, the energy of each X-ray photon that they managed to collect. After the managers and people heading the IXPE mission at NASA were convinced of this mission's authenticity, the spacecraft's green light was given to carry out this regular space observation. IXPE's detectors are designed to measure X-ray polarization from space. Bright calibrations have also been observed with properties that are known to help ground teams fine-tune the alignment of the telescope's mission. Speaking of the Cassiopeia A earlier, this IXPE observatory will observe it for about 3 weeks, and it is the first of 33 planned targets selected for the initial years of IXPE's mission. The flight plan has time of observations of about 40 targets overall in IXPE's first year of operations. IXPE will aim its telescopes at each target for days or multiple weeks at once. This will allow these telescopes to collect long X-ray exposures, which will allow scientists to separate polarized signals from background noise. The best part about this spacecraft is that it will be sent for X-ray purposes and that it will be having no need for any rocket fuel for pointing out orbital maneuvers. The future of IXPE. X-ray polarization can help scientists tell the spinning of a black hole. The theoretical calculations show that the degree of polarization of an X-ray signal manages to vary along with the magnetic field's energy present at the source. This is because black holes do not have many properties. The use of polarimetry to determine the nature of something as unknown as a black hole is fascinating. Black holes being unknown also goes down to their nature, as in general terms, they are considered voids of nothingness. This is why polarimetry might help us get a better insight into what black holes are supposed to be. As for future endeavors for IXPE, they include a supermassive black hole in the center of our universe known as a Sagittarius A. As per IXPE's measurements, this black hole was much brighter a few hundred years ago. Further study needs to be made to fully understand the astronomical level at which the black hole is. IXPE will also look into more distant targets, such as blazars at the center of galaxies. Blazars contain powerful jets of radiation that happen to be aimed directly at the Earth. This mission will also help study the polarization of X-rays coming from the magnetars. Magnetars have the most strongest magnetic field of any star that is present. Some are 1,000 trillion times more intense than the Earth's magnetic field. IXPE will do wonders if it is allowed to explore our space and beyond. With it making such huge moves right now, nobody knows how high the ceiling is for this project. We can only hope it exceeds expectations and reveals the secret that lies in our space. With so many ventures going on for NASA, this is truly one of those that could end up making a difference in how we see the great unknown.